Hi, this is Rob Brandt from the Fireside. I'm going to talk today about the 6-tube radio that was built a lot in the 40s and into the early 50s. The 6-tube was a better radio than the 5-tube that preceded it. Not taking anything from the 5-tube, it was a good radio. Its big limitation was sensitivity. It had decent selectivity. You could separate signals unless you had a very strong one sitting next to the one. Say you had a strong signal at AM 910 and you were trying to listen to a relatively weak one at 900 or 920. It might get dicey. The 6-tube didn't do anything really for selectivity, but what it did do was a good bit for sensitivity. It drove the sensitivity down maybe 10 or 14 dB, that you could hear a signal that was much weaker. Again, now you get a stronger signal next to it and it is even worse, but they were a good radio. Many of the 6-tube also allowed you to have an external antenna. And we're going to talk about that as we get through this. Let's start at the left side of the radio. The signal comes in off of an antenna, goes through a capacitor. The reason for that capacitor is because if you look backwards on that circuit through that L1, which was a antenna coil, it connects to a bus down below that's going to wind up being connected to the one side of the AC line. If the plug is in the wrong way, without that capacitor, the antenna would be hot. So that capacitor's there. That circuit is tuned by two variable capacitors. One of them has the dotted line to the other capacitors, the other capacitor, and a coil. That's one of the things that's kind of a little different. The second capacitor is not ganged. It's a screwdriver adjustment on the side of the capacitor, the variable capacitor, to help with alignment. These capacitors and this coil, frequency-wise, had to track. In other words, if the input one was tuned to 600 kilohertz and this one was tuned to 600 kilohertz, this capacitor had to be tuning this coil to 600 plus 455 is 1055 kilohertz, because this circuit would produce a oscillator signal at 1055 kilohertz, which would mix with the 600 coming in and produce 455 going out. The simple class on heterodyning, if you mix two radio frequency signals, you will get the sum, the difference, and the two signals coming out. And what you have to do is select the one you want. In this case, we would select 455. But if you looked at the difference, or 400 kilohertz, and that one would also be there, it could be a problem. Okay, let's go back and start at the beginning. The signals fed into the grid of the first RF amplifier. That signal is amplified by that, comes off of the plate. We have this tuned circuit, and there is a capacitor feeding the grid of the next tube. This is important, and we'll talk about it here, but this follows through in the rest of the radio. The plate here is connected to the power, which goes down and is probably at about 150 volts DC. This grid does not like 150 volts DC. As a matter of fact, that tube will kind of light up and burn out. We put a capacitor here which blocks the DC but allows the signal to go through. So the signal gets through to the grid, but the DC does not. This tube also functions as the oscillator, and coming out of it is the IF frequency. We have a tuned circuit here that only allows a small bandwidth to go through. Now, it's not a sharp bandwidth, meaning that, let's say that center frequency is 455 kilohertz. If you go down to 445 or up to 465 and put a signal through there, most of it will get killed. But if you take a very strong radio station, 10 kilohertz off, and feed it through here, some of that will get through. There's a second tuned circuit, again tuned to the same frequency. It will reduce that signal some more, and it's fed into the grid of another tube, which is the IF amplifier. Simply, IF is intermediate frequency. Basically, it's not the frequency that we're listening to, but it's a frequency we've heterodyned to so that we can do some real nice work of tuning very accurately. The output of it, there's nothing remarkable about this tube. The output of it is fed into another tuned circuit that is a transformer with a second tuned circuit. And we now have 4 tuned circuits that are bringing that bandwidth steeper, the sides of that, so that when we get off frequency, less and less of the signal comes through. We have an interesting circuit here coming off of the second IF secondary. You have a primary and secondary in a transformer. When you come off of this secondary, one of those that connects to one of the diodes in the tube, and the other one connects, and it connects then to the other diode through a capacitor. This is a little different than the 5-tube that builds the AGC a little bit differently. The first diode is used to produce signal here in the triode, audio signal. The second one is used to produce a DC signal that is fed back to the grids of the RF amp and the mixer. What that voltage does is biases down that tube. If that voltage goes up, these tubes have less amplification. It is referred to as AGC or AVC, automatic gain control or automatic volume control. They're the two names for the same thing. What they do is reduce the gain if the signal's strong, or increase the gain if the signal's weak. And the result of that is that you don't have to turn the volume up and down if you move from a weak to a strong signal or a strong to a weak. The 5-tube does this a little bit differently here with the 2 diodes, and they're actually connected in a different way, but it has the same function. The audio gets fed out of here to a volume control down below, where it's then fed through a capacitor into the grid of the triode. And then the triode amplifies it. And here again, we have a capacitor going out. And the capacitor is feeding the grid of the 35L6, which is the beam triode, out. We feed a audio transformer and the speaker. Remember, the beam triode has an impedance of several thousand ohms. We now have to get that down to about 8 ohms, that is the speaker. So we're going to have a ratio there of, let's say, 8,000 to 8 ohms is 1,000 ratio. The turn ratio is not 1,000 to 1. It is the square root of 1,000 to 1. Impedance ratios are square roots. There won't be a lot of turns on the secondary. there will be quite a few on the primary. Going back, this capacitor keeps the high voltage off the grid of the beam triode or the beam pentode. Kind of an interesting arrangement. This capacitor across the pentode does some shaping. The one across the triode also does some shaping. This one kind of keeps the RF out of the bottom end of the radio. I do not see a tone control on this anywhere. It would be another variable resistor, and there just isn't one. Looking down below, we have the power plug, and the one side of the power plug comes in and connects to the grid of the 35Z5. Goes back through the 35L6 filaments and the other filaments. On the 5 tube, this would have been a 50L6, not a 35. The reason is this only drops 35 volts of the AC. This drops 35, which is now 70. And if we add up 4 12s is 48, we're going to get to somewhere around 120. This would be in the 5 tube, this would be a 50 volt tube, and we wouldn't have one of these, which would again still add up to 150 volts. This avoids things being blown out. This radio also has something else that the 5 tube. Remember, the 5 tube was a cheaper radio, did not have quite as much quality in a lot of things. To reduce hum, this radio uses a pi network filter on the DC with an inductor and 2 capacitors in a pi configuration. An interesting thing also, it has a resistor with another capacitor. This thing would have had very, very low hum, very quiet in that sense, compared to the 5 tube. The 5 tube will have a little bit of inherent hum in the background. Now, I restore these. I've not restored a 6 tube, but if you look behind me, there's a 5 tube sitting there that I restored. One of the things that I do is down here where the power plug is, I cut that cord off. I take a 3-wire cord with a ground plug, because these radios were dangerous. If you got the plug in with the one side of it hot, you could have a hot chassis. As long as all of the plastics were there, keep you from touching any metal, and the capacitor on the antenna was good, you were fine. But you violated one of those and hit a ground, and you could actually be killed. So what I do is I put on a 3-pin plug. I ground the chassis to the green wire in the cord, the safety ground. The hot line goes to the switch. And I actually reroute this. And then the white wire to the filament string. This isolates everything so that there is no shock hazard. And by the way, I put a fuse in there too. I want these to not harm somebody or create a problem. I've had some fun doing these. I'm going to talk through another circuit later for a radio that was a portable tube radio. There were models of these that varied. Typically they had 4 tubes or 5, depending on some various things. The 5 tube model was much like this in a way, and had a 35 volt tube in it as a rectifier, and a switch that would switch it from being able to be plugged into the wall and operating off of 2 batteries, 2 D cells, and a battery that was usually either 67 volts or 90 volts for the plates. I'd like to talk about that one later. Again, this was a very nice radio. The Admiral 6A1 was a classy radio. This is Ralph Brandt from the Fireside.